Hello, and welcome to this demo where we will implement the RAG architecture using the Llama 3 chat QA model on Databricks. Uh, so we are gonna we are gonna use the vector database ChromaDB to store our embeddings and fetch the right embeddings as context to pass the unknown knowledge to the model as a part of prompt engineering. To achieve this, we would be importing the model from the Hugging Face. We would be setting up the ChromaDB, create a collection, store some earning reports of Nvidia and Microsoft as a part of that information, fetch the right one, and pass it to the model using Databricks. So please note that Databricks ML runtime, you need to choose the right runtime. The supported runtimes are 13.3x CPU and GPU both. However, I've noticed the CPU one is really slow with this particular model. So I've used GPU one for the sake of this demo. But please be mindful about the cost and use the right runtime that fits your budget and needs. Theoretically, both the runtimes are compatible uh, for this RAG architecture. That being said, let's jump into the next few cells. I'll quickly walk you through what we are doing into this notebook. Uh, and in parallel, I'll hit onto the run all so that we have the report results ready by the time we go there. So step one, I am installing the dependencies here. Please note that transformers from Hugging Face is required, and I faced issues with previous versions of the transformers and learned a lesson out of it. So for this particular model, you want to implement the RAG architecture, then use a transformers version greater than or equal to 4.31. And the other way around for the ChromaDB, um, initially I had used the latest and greatest version of ChromaDB available today. But that again gave me issues and I've learned my lesson out of it. So this particular version and the combination is working fine on Databricks today. So after the installation of these packages, I am restarting the Python kernel for obvious reasons for these changes to take effect into the notebook environment. All right, so into this step, into this cell, we are we are essentially building a prompt um, wherein there's a structure on how we are communicating with the model. So we are passing the system information and setting up the context to the model that this is a conversation between artificial intelligence system and the user. We also instruct through this prompt to the model that it should give us the full and complete answer to the question. So little tweaks and if statements in here, concatenation here. Essentially, it's creating a structure for our prompt. You will see the prompt in the next few cells. In this step, we are setting up the ChromaDB. You see we are importing it. And then we are doing some basic settings, providing the ChromaDB implementation. We are asking it to use the DuckDB with Parquet file formats, and then we are providing the persisted directory location of the S3. This is an optional argument, but um, yeah, but I've passed it for the sake of using the S3 location. This cell, we store the context knowledge into the vector store, the ChromaDB. So I've named my collection as context collection here. Um, creating that collection if it does not exist, and then cleaning up that collection with the delete command before I really add my two companies' earning reports as a part of my context information or the knowledge, right? So here you see the first document, it's the Nvidia earnings report of the recent year, and I'm passing an additional metadata to it as company as Nvidia, and passing the essential IDs for this particular document. So this metadata tag, the company tag, I'm going to use it to really filter the right document that I want to pass to my model via the prompt. So you will see this later in the following cells, but please note that I've used the company tag here. So I've added two documents, one for Microsoft and one for Nvidia. And here I'm just checking, whether both the documents are correctly added, so making a count of it. In this step, like I just mentioned, I want to pass a prompt regarding NVIDIA and get the detail from the model regarding NVIDIA. So what I'm doing here is I'm filtering the context information from the vector database. I don't want to pass all the documents to the model since my query is only going to be regarding the NVIDIA. So there's a way to kind of pass this where clause and get the right context information, uh, and then this context information I am passing in the following cell to the model. At this step, I'm importing the LLM from the Hugging Face, the Llama 3 chat QA with the 8 billion parameters. Like I said, there are two variants to this model available onto the Hugging Face. One is with the 8 billion parameters, and the other model is trained onto, I think, 70 billion parameters. For this purpose of the demo, I think 8 billion is sufficient, and that's why I've chosen this. So you can see um, passing the necessary details here: the model ID, the target D type, and the device map, the basic parameters that you need. This cell is going to take some time because it's going to actually download your model from the Hugging Face into your environment. Once this is done, we are building our prompt. Remember the function that we just saw a few cells ago? We are calling that function here to essentially format my prompt. So at the end of calling that function and using this list of string wherein we are passing the information like role is user and the content, this is the actual question that we want to ask to the model, right? So after formatting the inputs, this is how my prompt looks like. So essentially this is just an prompt engineering step, which is again a very key step into the generation models and the RAG architecture. You can improve the efficiency of the responses from the model by generating the right prompts, and this is one of the examples of it. Here we are passing some information as a part of the system. We are saying that it's a chat, kind of a communication between user and artificial intelligence assistant, and then the assistant should indicate when the answer cannot be found. So essentially, don't make up anything as a part of sentence formation, right? So we are saying that to the model, and then we are passing the context that we just fetched from the vector database, ChromaDb. Lastly, we have the user information here. So we are adding our instruction with the actual question that we have for the model. So we're saying, please give us full and complete answer to the question, and then here is the question. So it's essentially being concatenated into the get formatted input. So this is how my prompt is looking like, and I'm leaving the blank space for assistant to really respond to it here. Once my prompt is ready, I am just adding the basic information that I need to pass to the model, the tokenizer, and essentially we are using the same tokenizer that um, the model has used while it was trained. Um, yeah, so with that, we are hitting the generate command here out of the model, and we are passing the prompt inputs and the parameters like max new tokens. In this case, I'm saying I want the answers in 64 tokens max. Um, yeah, and that's it. Then when I run this, it took a few seconds, less than a minute here. You see 50 seconds for me. Um, and here is my answer. It says the percentage change of the net income, blah, 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 is 769% increase. So this information essentially is coming from the report that we have passed to the model um, with the RAG architecture, right? But please know, please note that it's not about the accuracy of the information. The purpose of showing this is how you can pass the domain specific information or the knowledge that the model does not have by default, right? May that be because the information was not ready when the model was trained, or you're borrowing the model from some other enterprise and you wanted to know the details uh, about your industry or your specific data, right? That's when the RAG architecture can be used. So this is an example of how you can really store the unknown information, the unknown knowledge into the vector database. Um, so the unknown knowledge in this case is your reports, earning reports of Nvidia and Microsoft. So we have stored that into the ChromaDB. We have filtered the right report to pass to the generation model. In this case, we have used Nvidia, and then we have passed it as a part of the prompt. And this whole approach of what we have done is nothing but your RAG architecture. So that's about implementing RAG onto the open source LLM model, in this case Llama 3. Thank you for your time.